Alright, section 3.1, part 1. We're going to talk about systems of linear equations in two variables, and this is something you did in Algebra 1 and Algebra 2, and we're going to focus on it first a little bit to make sure we're really good at it, because it's the easy part of the chapter, and after this it's going to get harder. So we're going to start off by solving by graphing. First thing I want to talk about, though, is what do I even mean by system of equations? What I mean is we've got something like this right here. This is an example of a system of equations. And the key features is there are two equations, which is why it's a system, because there's more than one equation. And we would call this a system of equations in two variables, because I've got two variables in each of my equations, an x and a y. Now there are three types of answers to a system of equations, three different scenarios we can have. Most of the time we will end up with a point as our answer, an x comma y. We'll know what x equals, we'll know what y equals. But sometimes we end up with one of these cases down here. Infinitely many solutions means there's more than one solution. There's actually a ton, as many as you can think of, solutions. And then lastly, sometimes we end up with no solution, where there's not an answer to a system at all. So let's start off by doing some graphing. Example 1. So this requires us remembering how to graph. We start with the -4 in this first equation. Okay, this first equation. We start with the -4 and we draw a point at -4. Okay, there's my point. And then we take our slope, which remember that slope is rise over run. We take our slope and we say, okay, I need to go up 7, right 4. So from that -4 I drew up 7, right 4. It's right here. So we have a line that's going between those 2 points. Now let's do the second one right here. So now we're starting at +4 on the y-axis, and then -1/4 as our slope. We need to think of that either as -1 over +4 or +1 over -4. If I say -1 over +4, I'm going down 1 and then right 4, which helps me find out where we're intersecting. If I do the other way and go up 1 and left 4, see how that's going to work out? So our line goes through these points. Okay, and you didn't really need to draw out the slope. I just realized you couldn't really see what I was motioning with unless I drew it. But here's what's important. This point where they intersect, that's a point x comma y. The x value is 4, the y value is 3. Our answer to this problem is 4, 3. Well, let's try another one. Now, graphing this first one, I have 2 for the y-intercept, which is where I start. -x, okay, remember what's in front of x if I don't have a number there? A 1. So if I have a slope of -1, it could be -1 over 1, or it could be +1 over -1. Either way, like down 1, right 1 would be the first way, up 1, left 1 is the second way. The more dots you draw when you're doing this, the better, because here in a sec, whenever we draw our other line, if we've already got a whole bunch of points, it's going to really help us figure out where they intersect. Okay, so then on the second one we have a -2 for a y-intercept. We want to go, since this is not a fraction, we want to make it a fraction, because that's up 3, right 1, which, oh, there it is, right there. There's our intersection. Okay, and so that point where they intersect is 1, 1. Now, one more before we change things up a little bit. If I graph these, if I start with the first one and I do -1, then just like in the last one, we have a slope of -1, so we go down 1, right 1. Well, we'll pretend that's a straight line, right guys? Okay, so we start at -1, we go down 1 over 1, and then whenever I do the second one, I start at 2, and oh wait, I'm going down 1, right 1 again. Now, it'd be nice if my lines were a little straighter, but I think you can get the picture here that these two lines should never meet because they're parallel lines. And in fact, whenever we talked about parallel lines a little bit last chapter, we said, hey, if we've got the same slope, we have parallel lines. So the answer to this, and the answer to any system, is where do they intersect? But here they don't intersect, so our answer would be no solution. That's one of the special cases that we talked about. We've talked about how to get a point in the first two examples. Now here's no solution. If you're curious what infinitely many solutions would look like, if we graph something and you graph it, okay, get this line, let's say, and then when you go to graph the second equation, you get the exact same line, that's infinitely many solutions. Because if the lines are right on top of each other, then that means they touch at a whole bunch of different points. So that's the case of infinitely many solutions. But because of how weird that is graphically, you shouldn't get that as an answer as far as like on our worksheet goes. Now, solving by graphing, here we can't solve right off the bat because we're not solved. We can't graph it right off the bat because we're not solved for y. So subtract the x from both sides on this first one, and that gives me negative 3y equals negative x minus 9. Divide everything by negative 3. We get y equals, this is like a negative 1x, so that's a positive 1/3 x plus 3. Then on this next one, minus 2x from both sides. We get y equals negative 2x minus 4. So these are the two lines we're graphing. So starting with the purple one, we start at 3, we go up 1/3, and then we can go in the opposite direction. So we've got this line, then our blue line, negative 4, go down to right 1, and now we can see where we intersect. It's right there at negative 3, 2. There you have it.